from rubber trees has a milky substance called what? Latex. The most important thing that you need to know in O level, now you should be noting down this. The most important thing that you need to know in A level is here, is what we call vulcanization of rubber. Vulcanization of rubber. Now, the rubber that is obtained is not very strong. Rubber in its natural form, which is obtained from trees, is not very strong. But there is a process that we do to make that rubber very strong and elastic. And that process is called vulcanization of rubber. This is very, very, very important. Vulcanization of rubber. What is vulcanization of rubber? Vulcanization of rubber is the process of heating rubber with sulfur. Please, you must always remember that vulcanization is a process of heating rubber with sulfur to make it stronger and elastic. So vulcanization, which involves heating rubber with sulfur. I repeat, vulcanization is the process of heating rubber with sulfur. Vulcanization is the process of heating rubber with sulfur. Now, this is also, having known that vulcanization is the process of heating rubber with sulfur, this is very, very important. We could ask you, what are the advantages of using vulcanized rubber? Why do we use vulcanized rubber? I know most of you, you have never bought yourselves a pair of shoes, but your parents have always bought for you. But when they go to buy shoes, the first thing you do when you want a strong shoe, you look at the sole. You look at the sole. So they first bang the bottom, on the bottom, and find out, is the sole rubber or not? If it is not rubber, then most likely they may not pay for the shoe. And that is vulcanized what? Rubber. And there is also another thing they do. If you have ever seen those who sell shoes and buy shoes, they first fold the shoe to show you that it is rubber, which is elastic. They first fold the shoe from the bottom, fold it very many times to show you that it can be made, it is flexible. So that is vulcanized rubber. So vulcanized rubber is rubber which has been heated strongly with sulfur. So we heat rubber with sulfur to make it stronger. Check what I have highlighted: to make it stronger, to make it more elastic, and to make it more durable. That is vulcanization. Now, this vulcanized rubber has many uses, but if we ask you for one use or two, then these are the most important uses. This vulcanized rubber, which is now very hard, durable, and elastic, it is used in manufacture of tires, car tires. Those tires are made of vulcanized rubber. And it is also used in manufacture of footwear. Footwear, you know what I'm talking about. Most of you, your soles are made of what? Are made of rubber. Advantages of artificial or synthetic polymers: they are cheap, low production, then they are usually stronger and more resistant to corrosive substances like acids, then they can be modified depending on the purpose. So those are advantages. They are resistant to corrosion by acids and other substances, then they are cheap. Disadvantages of synthetic polymers, most especially polythene. The disadvantage that I wanted you to write and is here, and it is this one that you should always write. Two disadvantages of polythene, they are here. It is non-biodegradable, causing pollution to the environment. That is polythene. Kavera. You remember the campaign to Tuve Kavera. Because they are non-biodegradable, which causes pollution to the environment. Okay? When burnt, they produce toxic gases like hydrogen cyanide, thus endangering lives of people who work in factories. So that is also another disadvantage. Now, let us focus our attention on alcohols. So we have finished talking about rubber. We are now on alcohols. What is an alcohol? We are saying alcohols are organic compounds that have this group. Any organic compound that has the group of OH hydroxyl group attached to the carbon atom is an alcohol. So the definition is here. Alcohols, these are organic compounds with the hydroxyl group attached to the carbon atom. That is the definition of alcohols. Now, alcohols are very many, but in all alcohols, for O level, we are going to focus our attention on ethanol. So the molecular formula is here. It is CN H2N plus 1 OH, meaning if N is 1, then the molecular formula will be CH3OH. And if N is 2, the molecular formula, write this, when N is 2, the molecular formula will be C2, H2N plus 1, that is H5OH, right? When N is 2, we have C2H5OH, and this is its structure formula. You need to know this. This is the structure formula of ethanol, which we used the other time in preparation of ethene. It is C2H5OH. That is the structure formula of ethanol. And the name is ethanol. So I've told you, among all alcohols, we are going to focus our attention on ethanol. Physical properties of ethanol. It is a colorless liquid, that one we know. Then it is a volatile liquid and boils at 78 degrees centigrade. I think this one, you don't dispute it. We looked at it in our senior one. Ethanol boils at 78 degrees centigrade and water boils at 100 degrees centigrade. And because those two have boiling points which are near, they can be separated by fractional distillation. Then another physical property is here. It is soluble in water. Who can tell me one word to mean that ethanol is soluble in water? So what name do we give to those two liquids which dissolve in each other to form a uniform solution? Beiza, what name do we give to liquids which dissolve in each other to form a uniform solution? Base, I don't like people who don't answer. We are saying ethanol is soluble in water. Now I am asking, what name do we give to the liquids that dissolve in each other to form a uniform solution? Someone tell us. Someone, please, faster.
Miscible liquids.
We call them miscible liquids. Miscible liquids are liquids that dissolve in each other to form a uniform solution. And what about liquids that do not dissolve in each other? What do we call them?
Immiscible liquids.
Very good. We call them immiscible liquids. So let us now look at chemical properties of ethanol. We look at chemical properties of ethanol. Number one is combustion. Ethanol, like the other hydrocarbons, what did I tell you are the products when hydrocarbons burn in excess oxygen? I told you the products will always be carbon dioxide and water. So ethanol also burns completely. Ethanol also burns completely in air with a blue non-luminous flame, producing carbon dioxide and water. And this is the equation. Ethanol, we have agreed its molecular formula is C2H5OH. Let us not forget that C2H5OH is the molecular formula of ethanol. So when ethanol burns in air, the component of air that supports burning is oxygen. So when ethanol burns in air, they are saying product is carbon dioxide and water. Okay, the product is carbon dioxide and water. So to balance the equation, you have to put 3 on water, then 2. Actually, you begin from carbon, because the carbon atoms are 2 for ethanol, so you need to put 2 here. Then when you put 2 here, oxygen will become 4. Okay? Okay? Oxygen will become 4. And when oxygen becomes 4, you also need to balance hydrogen. On the left-hand side, hydrogen is 6. So you should put 3 here to make it 6. And when you put 3, oxygen becomes 4 plus 3, which is 7. And since this is already 1, you put 3 here to make 6 plus 1, which is 7. Dehydration. We have been talking about this. I don't think I need to talk about it again. When a little concentrated sulfuric acid. Now, don't waste your time looking at this first paragraph. Leave this one for A level. For you, the only thing you need to know in O level is that when concentrated sulfuric acid is heated with ethanol, it produces ethene. So if you are noting down, this is the only thing you need to know. When concentrated sulfuric acid is heated with ethanol, it produces ethene. And I repeat, the conditions are sulfuric acid must be concentrated, sulfuric acid must be in excess, and sulfuric acid must be heated at a temperature of 170 to 180 degrees centigrade. Now we go to preparation of ethanol. This is also very, very important. The question we ask is preparation of ethanol on large scale. We have manufacture of ethanol on large scale, and that one is usually done in villages using locally available materials. And the other question which we ask is preparation of ethanol. Now, preparation of ethanol, here I'm talking about laboratory preparation. How do we prepare ethanol from the laboratory? And I'm saying ethanol is manufactured or prepared by a process called fermentation. You must never forget this. The process by which ethanol is prepared is called fermentation of carbohydrates such as starch and sugars. But the process we are saying is called what? Fermentation. And mark the spelling. When you write it, the spelling must be correct. So what is fermentation? If I ask you to define fermentation, what do you say? Fermentation, this is a process in which carbohydrates like starch and sugars are converted to alcohol by enzymes. I repeat, fermentation is a process in which carbohydrates like starch and sugars are converted to alcohol by enzymes. Fermentation is a process by which carbohydrates like starch and sugars are converted to alcohol by enzymes. The enzymatic breakdown of glucose yields simple compounds like ethanol and carbon dioxide. Some heat is as well generated, so heat energy is generated as well. So let us look at preparation of ethanol from starch. The process we have said is fermentation. So starch is heated with malt at a temperature of 60 degrees centigrade. Malt contains enzyme diastase, which hydrolyzes starch to maltose. So the first enzyme is diastase, and diastase hydrolyzes starch to maltose. So this is the formula of starch, C6H10O5 plus water, and it forms maltose. And the enzyme that does the work is called diastase. So yeast is added at room temperature, and yeast contains two enzymes, maltase and zymase. Maltase catalyzes the hydrolysis of maltose to glucose. Maltase and zymase. Then maltase catalyzes the hydrolysis of maltose to glucose. And maltose, the formula for maltose, I think you do this in biology. This shouldn't be a problem. The formula of maltose is C12H22 water. Now let me simplify this for you. Write these three equations. They are very important and they are examinable at your level, your O level. First, write the three equations, then I tell you what to do. Now, on the first equation, on the arrow, put there diastase. We have three enzymes that participate in preparation of ethanol from starch. Write these three equations only. Then on the first equation, you put the enzyme on the arrow here, and the enzyme we have said and agreed that it is diastase. Now, when maltose is formed, we add yeast, and yeast contains two enzymes, that is maltase and zymase. Now, maltase, it converts, oh, no. Something has gone wrong with my, let me see how to modify it. Yes, I think that is it. So I was telling you that maltase converts maltose to glucose, and when you have glucose, you are almost done. From glucose we get ethanol. So most of the time they can tell you to start from one equation, which is that one of ethanol. So sometimes they tell you to start from this equation, which is ethanol, and the enzyme there we have seen is zymase. Zymase is the one that converts ethanol, that converts glucose to ethanol. So these are the three equations. Now this ethanol that is obtained is not pure. The ethanol that is obtained is not pure and can be purified by using fractional distillation. Now, I will give you an assignment in the remaining time, and the assignment that I want to give you is to tell me how ethanol can be prepared from locally available materials. For us in the West, we use bananas. Then I know those people from Teso, for them, they use millet. Then there are those from Guru. I don't know if they use cassava or what, but all of them, in every region, there is ethanol. So for you can use one for your region, but ethanol can be prepared from millet, can be prepared from bananas. So you have the notes, and the procedures are here. So that is what I want you to do for me. From bananas, it is also there, and from what? From millet, it is also there, and it is what we shall be focusing on next time. So as I conclude, I repeat that preparation of ethanol from starch, I told you to write these three equations. The first equation is starch being converted to maltose, and the formula of maltose is C12H22O11. So you just add water to starch, which is carbohydrate, like crushed cassava, like that. Then you add water. Then malt contains, starch is heated with malt. That's the first step. Malt contains an enzyme which is called what? Diastase. And diastase converts starch to maltose. So we have malt and yeast. We have malt and what? Yeast. Malt is heated. Malt is heated with starch, and malt contains an enzyme of maltase. And maltase converts starch to what? No. Malt contains an enzyme diastase, and diastase converts starch to maltose. Then we add yeast. Yeast contains two enzymes. It contains maltase and zymase. Maltase converts maltose to glucose. And finally, zymase breaks down glucose into ethanol. I repeat, these three equations are very, very important, but the most important one is the last one, where glucose is converted to ethanol, and when ethanol is formed, it is formed with carbon dioxide. It is formed with carbon dioxide and heat. So if there is no question, I wish to end here. I don't want to give you very many things that will confuse you. Do you have a question? Any question from you people? Have you written these three equations and put the enzymes I told you to put there? Because when we ask preparation, at least even if you don't know the words, you should remember the three equations such that you get marks on the equations. Have you written the equations? Is it a must to add plus heat? Someone is asking. It is not a must, but it is better to add it because it is given out in form of energy. Okay, I wish you a good day. God bless you. Bye-bye. I'm sending you assignment, yeah? Okay? So from here, just go to Google Classroom. Bye-bye.
Bye.